Since the start of the COVID pandemic and the surge in online activity, online casino networks have seen a massive explosion in both user and revenue. Personally, I like to gamble, but I prefer to do it in video games like Path of Exile or any other games that don't involve real money, because it's easier to control addiction when the loss is limited to time rather than real money. But ultimately, most games of chance are closely tied to the probability of an event occurring. Today, we're going to look at a basic dice game and probability. If we roll a 6-sided dice, we are asked to pick a number between 1 and 6, which gives us a 1 in 6 chance of getting it right and a 5 in 6 chance of getting it wrong. So when you think about it, this game isn't really fair. But as a professional gambler, you can also calculate how fair or unfair it is in terms of cost of entry versus the payout. To do this, you can simply use the expected value formula which is shown on the screen. For example, in a dice game where I bet $5 with a 1 in 6 chance of winning, I will need a payout of at least $25 to be profitable in the long run. Once you move beyond using a single 6-sided dice, the game becomes extremely interesting, because you can use math to figure out which number are the best to bet on. With two 6-sided dice, if you list all the possible outcomes, 7 is the most common number. But you could have figured that out more simply by calculating the average of the dice. By the way, the video is already 1 minute and 30 seconds long, and just in case there is any viewer under 30 watching this, here a 5-second reset. La Poupou. Minecraft, Subway Surf. Okay, so now that we've reset people's attention span, we need to add a small detail to the two 6-sided dice, because the probability drops dramatically depending on the choice you make. And yes, the decision to display the result as a bell curve was intentional, even if it doesn't look great. So now that we have the basic down, it will be nice to see some results. I'm not going to bother rolling two 6-sided dice 10,000 times to test this. That will take way too long. But my friend Python along Matplotlib already has everything I need to visualize this data. If you roll two dice just 10 times, you could theoretically get a total of 2 or 12 every single time, which is extremely unlikely, but that's still possible. With a larger number of trials, for example 10,000, the results tend to converge towards the expected distribution. So you're telling us we have to bet 10,000 times to win at a dice game in the casino? Well, yes and no. It's still gambling either way. But we choose 7 because it's come up the most often. But 7 might never come up, just like when the tax call me. It's kind of a mix of the probability that an event will happen and the expected value you'll get out of it. But then again, you could really be unlucky and it might never happen. So even though we use math to prove a few points, it's still gamble, so don't forget to enjoy the game.